Hello, I'm Magnus Johnson from the University of Hull, and I'm very pleased to be able to present some work to you uh, that we did where we asked skippers of small-scale fishing boats about the potential for electrifying their propulsion systems. So I did the work with Sergei Rubchenko, who's an electronic engineer, and Simon Waldman from the Energy and Environment Institute, all at the University of Hull. The work was facilitated by the National Federation of Fishermen's Organisations and funded by the Fisheries Seafood Scheme. So what we did, we travelled around the country. We went up to Orkney, we went to Yorkshire, and we went down to Devon, and we interviewed skippers on the quayside. We basically ambushed them and asked them, what do you fish for and how powerful is your engine, how much fuel you use every week, what's the pattern of your boat use, how far do you travel to your grounds, and how do you feel about electrification? And I must say that to the last question, most people were very positive. So most skippers could see the advantages in switching to electric, both from a sustainability point of view and from an economic point of view. The reason we went to all these different ports was because they have different assemblages of boats. So Yorkshire is very much dominated by the potting fleet who use static gear, and whereas Devon has a much sort of bigger diversity of boats in the small scale sector, so trawlers, dredgers, divers, as well as potters and netters. So when you look at small scale boats and you compare engine power by type of boat, so depending whether they're trawlers or dredgers. So the ones that use mobile gear, that are dragging gear through the water, dredgers and trawlers, have higher powered engines than those that use static gear, netters and potters. Similar story with fuel use. So you tend to find that trawlers and dredgers use more fuel per week than potters do, because they work in different ways. So a trawler leaves a harbour at between 70% and 100% of its maximum power, goes out to its grounds, throws its nets in the water, and then drags them around to catch fish. So they're using power all the time. Static gear boats go out to their gear and then they can put the engine on idle or they're on low power and they're just using a 1-ton hauler to pull their gear aboard and stack it aboard, and then they're throwing it overboard again. So they work in different ways. So a static gear boat isn't on full power all day. A trawler is on full power all day. And that's a critical difference. What it means is that we thought, after we looked at this, we thought that the real potential for hybrid systems or electric systems is with boats that are fishing using static gear. And so when we talk about hybrid, we talk about a system where you have an electric motor, which is depicted in black, you have a generator, which is in blue, and you have a battery, which is depicted in red. Now, the difference between using a generator and using an engine is that the generator can be running at its most efficient rate all the time, whereas a direct drive from a diesel engine, the engine's going up and it's going down, it's going up, it's going down, changing its efficiency all the time. So when you have these three components, depending on the combination of battery size and engine size, we'll go for one here where we've got 10% power from battery. So 10% of the day could be powered from battery alone on this particular system here. You see the boat leaves the harbour, it has the generator running and it has the engine running at full chat, and then when it gets to the grounds, the generator runs for a while until it's charged the batteries to 100% and then switches off and the batteries run down during the day while the boat is moving around its gear. So that we estimated that with this combination of generator running at 100%, so that when the engine is not turning over, when the boat's working with its gear, it's basically the engine is running at idle. And in a diesel boat, that's a bad thing because the engine's just turning over. It's not doing anything. It's just using diesel. Electric motor, when it's switched off, it's off. And what we found was that skippers don't like turning a diesel engine off at all. So that, we think that they can get a 40% saving in fuel by using this combination here. One of the hurdles, though, is that if we're going to move to electric, it's even more efficient if the boats can be fully charged when they leave the harbour. And what we need is to have these kind of charging points on the quayside so that boats who will have significant demands for electricity to charge up overnight, for example, can do that. Fortunately, there's a bit of synergy here because all these piers in the UK, at least, that used to be covered in nets when fishermen were mending their nets are now covered in cars and have become car parks, lucrative schemes for councils to generate money from harbours. But if with the advent of electric vehicles, then these car parks are having to develop more and more electrical points that boats can charge up at. So there's a synergy there. There's a potential there for boats to be able to come up alongside and plug in and charge up overnight. It's not that difficult to take charging points from the car park down to the quayside now. So that's useful. But what we found are sort of basically in summary, if boats are going to make that jump from diesel, which is 20 times more power dense than the best lithium battery can be, everything becomes about efficiency. The boats have to be efficient. So we need efficient propulsion systems that maximize power for minimum input. We need more efficient boat designs. When you have a filthy big diesel engine in a small scale boat, it doesn't matter what the shape of the boat is. There's lots of power there to push it through the water. When we have to be much more efficient, then you find that you have to change the design of the boat. So the design of the boat will have to be much more hydrodynamic than the current vessels are. Infrastructure needs to be there in order for these boats to be able to charge overnight. Behaviour has to change. So we found that just by monitoring a skipper and asking him constantly how much fuel are you using, so with the monitoring systems in the wheelhouse, there was a 25% saving in fuel. And there needs to be efficiency. There needs to be policy that encourages decarbonisation and opens up opportunities for fishermen. So if you want to know more about this project, there is both a film, this QR code here, and there's a full report at this QR code here. Thank you for listening.